Texan Global School. Multiplication and division of algebraic fractions. The processes to perform multiplication and division of algebraic fractions are analyzed. The product of two fractions is a fraction whose numerator is the product of the numerators and whose denominator is the product of the denominators. Let's look at the first example. We will perform the operation of 4/5 by 2/7. We multiply numerators directly, that is, 4 times 2. And then we multiply denominators directly, 5 times 7. By performing the products results 8/35. In this second example, we have algebraic fractions multiplying. So, we repeat the algorithm. We multiply numerator by numerator and denominator by denominator. We use grouping symbols to indicate the products. Now, we associate numerical coefficients and variables. We then obtain the prime factors of the numerical coefficients to simplify. The prime factors of 4 are 2 and 2. The prime factors of 6 are 2 and 3. Since we only have factors in the numerator and denominator, we can cancel identical factors. We then cancel 2 with 2 and 3 with 3. We use the laws of exponents to simplify the variables. Equal bases multiplying, the exponents can be added. Hence, factors with equal bases divided, the exponents are subtracted, resulting in 2x squared over 3y to the fourth. In this next example, we also have two algebraic fractions multiplying. Before performing the product, we will factor polynomials. Both factorizations are trinomials of the form x squared plus bx plus c. We look for two numbers that multiplied results the independent term, and added the numerical coefficient of the linear term. The factorization of x squared plus x minus 2 is x plus 2 times x minus 1. The factorization of x squared minus 3x minus 10 is x plus 2 by x minus 5. We substitute the factors for the polynomials. We perform the algorithm to multiply fractions, numerator with numerator and denominator with denominator. Now that we have a numerator and a denominator, we can cancel identical factors. We cancel x plus 2 with x plus 2. We can also cancel y cubed with y cubed. Now we simplify the factors with base x, since they are all factors in numerator and denominator. Using the laws of exponents, we can move x squared to the numerator as x to minus 2. In this way, we subtract exponents obtaining x. We can see that there are no more identical factors, nor variables that can be simplified. Hence, we obtain x by x minus 1 over x minus 5. We can also perform the product of the numerator, thus obtaining x squared minus x over x minus 5. On the other hand, the division of algebraic fractions is performed by obtaining the multiplicative inverse of the divisor, and then doing direct multiplication, numerator with numerator and denominator with denominator. In this example, we will divide 7/3 by 5/4. We first find the multiplicative inverse of 5/4, which is 4/5, since if we multiply 5/4 by 4/5 results 1. Once the multiplicative inverse is obtained, we multiply 7/3 by 4/5. We then get 28/15. In the following example, we will perform the division of the two algebraic fractions. We then obtain the multiplicative inverse of the divisor. In a simple way, we simply change the numerator for the denominator and denominator for the numerator. This implies that instead of dividing, we multiply. Then we do the direct multiplication, numerator with numerator and denominator with denominator. We associate factors and obtain prime factors of the numerical coefficients to simplicity. We then cancel 3 with 3. Finally, we simplify using the laws of exponents, adding factors with equal bases, and then subtracting equal bases that are dividing. So, results 6a cubed over 5. For this example, we will repeat the process. We change the divisor for the multiplicative inverse, inverting the numerator and denominator. We can see that we have polynomials in the numerators and denominators that can be factored. We then analyze and identify the factoring cases. First, we have a difference of squares. Hence, x squared minus 4. It is factored as x plus 2 times x minus 2. In the next case, we first obtain a common factor, and then we have a trinomial of the form x squared plus bx plus c. So, x squared minus 4x plus 4 is factored as x minus 2 by x minus 2. The other trinomial x squared plus x minus 6 is factored as x plus 3 times x minus 2. Finally, we have a trinomial of the form a, x squared plus bx plus c. Using the cross method, we can see that 2x squared plus 3x minus 2 is factored as 2x minus 1 times x plus 2. Once all the polynomials have been factored, we perform the multiplication directly, numerator with numerator and denominator with denominator. Now we cancel identical factors, x plus 2 with x plus 2, x minus 2 with x minus 2. The other x minus 2 is also cancelled with x minus 2. Then we obtain x plus 3 over 2x squared minus x. In this last example, we have two operations, a division and a multiplication. When the operations with fractions are multiplication and division, first change the divisions to multiplication using the multiplicative inverse. So, we first obtain the multiplicative inverse of the divisor by changing the numerator with the denominator. Then direct multiplication is performed, numerators with numerators and denominators with denominators. We associate factors and separate prime factors to simplify. We apply laws of exponents. For those factors with equal bases, we add exponents. For those variables dividing, the exponents are subtracted. We obtain thus x cubed, y squared, z squared over 2. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com